Today is Unit Circle Day 2. Now, you don't need to memorize the unit circle this year. You'll be given it as part of a formula sheet for the semester. However, the more comfortable you are with it, and the more familiar you are with it, the better off you'll be. Much like law of sines and cosines, the last unit, the more you know about it, the easier it is to use. So, we're going to show you how to build the unit circle and then some tricks of the trade to get around it. You can kind of divide the unit circle into two pieces. One would be the 45-degree angles in the unit circle, and the second one would be the 30-degree angles in the unit circle. So we're going to show you how to find the radians and what the points are for those radians, because we want you to transition your thinking from degrees into radians. So we start off, our initial is at the right side on the x-axis, which would be 0. Okay, our first radian on the 45-degree angle would be pi over 4. Okay. Now, if you think about the 45-degree angles in the unit circle, there are 4 on the top and 4 on the bottom. So if you can count up to 8, you can find all the radians. Also, going back to the 45, 45, 90 triangles, you should know that the sine and cosine of 45 degrees are both root 2 over 2. So that is x, that is y. Remember from the last day of the unit circle that the x is the cosine and the y is the sine values. We keep going on, we have 2 pi over 4, which you reduce to be pi over 2. We go again, we have 3 pi over 4. In this case, the cosine is going to be negative root 2 over 2, and the sine is going to be just root 2 over 2. Notice the x value is negative because it's in the second quadrant. As we move along, you're going to get 4 pi over 4, which reduces to just be pi. Right. Then we have 5 pi over 4. Now both the x and the y are negative because you're in the third quadrant. Continuing, we have 6 pi over 4, which can be reduced to 3 pi over 2. 7 pi over 4. Now the y value is negative, but the x is still positive. And then 8 pi over 4, which is 2 pi, at the end of the unit circle. So one revolution around, we counted up to 8. We reduced the fractions as we did so, and we found all the 45-degree radians. Okay, next, we're going to do the same thing but with the 30 degrees. All right, the first 30 degrees is pi over 6. Now that's because there are 6 pieces of 30 degrees on the top of the unit circle and 6 on the bottom for a total of 12. So just like with the 45, so if you can count to 8, in this case, if you can count to 12, you can find all the radians. So you have pi over 6. The cosine of 30 degrees is going to be root 3 over 2. The sine of 30 degrees is going to be 1/2. Again, from the 30, 60, 90 triangles that we did in the first unit. We continue on. We get pi over 6. Reduce that, you get pi over 3. So the cosine of pi over 3 is going to be 1/2. The sine of pi over 3 is going to be root 3 over 2. Notice it just reversed. Continuing, we get 3 pi over 6, which is again pi over 2, just like it was for the 45-degree angles. Continuing on, we get 4 pi over 6, which is 2 pi over 3. In this case, because we're in the second quadrant, the x terms will be negative, the y terms will be positive. As we move around some more, we're going to get 5 pi over 6. Again, the x's are negative, the y's are positive. And then finally 6 pi over 6 to get you pi. So that's the top half. We're going to continue on. We counted to 6. We've got 6 more to go. Here's 7 pi over 6. Now both the x's and the y's are negative because it's the third quadrant. And we have 8 pi over 6 can be reduced to 4 over 3. 9 pi over 6, which is again 3 pi over 2, just like it was in the 45-degree radians. 10 over 6 is 5 pi over 3. 11 pi over 6. And then 12 pi over 6, which is 2 pi. So again, if you can count to 12 and reduce as you go, you can find all the radians with its corresponding points. Okay, now there's a lot of stuff in here. A lot of it looks the same. We're going to give you some tricks on how to figure this out. Okay, here's the unit circle all together. Now, you'll notice here, if you have the pi over 6's, all the radians that have 6 as their denominators form a rectangle. And all those points that correspond with those radians are always all the same in terms of the order. They're all root 3 over 2, comma 1/2. Excuse me. just with different signs. So the 5 pi over 6 is just a negative x. The 7 pi over 6 has negative in both the x and the y. And the 11 pi over 6 is just a negative y. But if you know one of them, you can use this rectangle to find the points for the other ones. Okay? Same thing can be said for the pi over 4s. They form a tall rectangle. So all those have pi over 4 in them. I'm sorry, these are the pi over 3s. Pi over 3s. My apologies. They're color coded. I missed it. Okay. So at the pi over 3s, they all start with 1/2, comma, root 3 over 2. You follow the rectangle around, you can find all those points. And then finally, now here's the pi over 4s. They form a square. Okay. And those are all going to be root 2 over 2s with different signs. So generally what happens is students do well with the pi over 4s because they're always in the middle of the pieces of your unit circle. But they have some problems with remembering which way the pi over 6s and pi over 3s go. So, little hint is this, okay? So 30 degrees is root 3 over 2, comma 1/2. Or is it the 60 degrees, which is 1/2, comma root 3 over 2? Okay, and the way we can figure this out is that root 3 over 2 is about 0.866 versus 1/2 is 0.5. So if we're looking for the x value of these points, the 0.866 is bigger than 0.5. So that means as you cross the x-axis, the longer one, root 3 over 2, is going to be the one where is going to be the one at 30 degrees. Okay, whereas the shorter one at 1/2 or 0.5 is going to be the one at 60 degrees. So it kind of might help you figure out which point goes where or starts at least. Okay, so that's one way to think about it. Okay, now we're going to use these unit circle values. All right, you have to be able to understand the corresponding radians with its points and what values you have for sine, cosine, and even tangent. I'm using these in a little bit to do some coterminal stuff and some simplifying. All right, good luck with the homework. It's pretty short. It's just filling out the unit circle and doing some review stuff from this unit. And I will talk to you later.